These batteries go right back down to standing, and we're going to test this battery at 100 amp hours. And it says there's 90% capacity in it. And now we're going to take power off and at 100 watts. We're going to take it off. So we're going to time this out to 5 minutes, and then we're going to ask the machine to put it back in 5 minutes that we take out. We're going to do it from these little bitty batteries, and you can see the size compared to this battery. So there's no possible way that this battery can charge that big one. But we'll take a measure of those right now.
So we'll let it light up for 5 minutes.
Well, we got it on time here, and it'll time, and then we'll put that charge that we take in, we'll put the charge back in the batteries. Okay, so these batteries are sitting at 14 volts. So they're fully charged, supposedly. They're sitting at 14.54 volts. 3 minutes to go. Okay, so we're taking the energy, this 100-watt light bulb. So we're past the normal draw of the 100 amp hour battery. We're around 9 amps draw from this battery right now. In other words, the C20 rate, discharge rate for this battery is about 2 amps max. And so we're more up like on the C5 scale. So we're asking it to do a lot. Okay, we're ready to go. So now what we're going to do is we're going to take another capacity test to see where the battery's at. Okay, we're at 81% capacity. So we've actually taken, 10% of that out. Okay, now, what we're going to do is we're going to show you what the signal looks like first. Let's see here. There, now the pendulum, this is what the signal is going to look like. That's the only signal there's going to be. Okay? Now we're going to put this on here. Oh, let's see here. Clamp the battery on there. We're going to start the machine. Okay, and the way this machine works is the motor force, you can watch this real quick here. The motor force drives it back and forth each time, but gravity brings it back down. So it comes across the pole piece really quick. And what we want it to do is get gravity to get it up here so it comes across the pole piece quick. And we're going to do this for 5 minutes. So what's happening is there's only one motor push on each swing. And when the impedance is equal, this will be up at 90 degrees. And see, we're using a very high impedance in the front and a very low impedance in the back, so it's sort of like what Tesla was doing. And we can look at the voltage. So you can see there that it's swinging this battery back and forth. That's driving the pendulum. All it's driving there is the trigger, because it's not capable You know, if it wanted to balance with the batteries, it wouldn't be at a 14 volts. All right. So what we want to do is we want to give this 5 minutes with this signal wave that's aided by the gravity wave, which works with the pendulum. And then we'll check this battery. We should be back up to 90% capacity. We can take another 100 watts out of it. So it's an impedance-driven machine. You know, same as the SG circuitry, only done in a pendulum. Kind of like a big TikTok. That's okay, you should have seen these things swung up to 90 degrees. It's scary when the magnet's this big. You know, this is scalable. This is scalable. You have one scale here, you have another scale there, and then if you get your camera back over here, you have one more scale yet, which is right here. Believe me, that has swung up to 90 degrees right out there. Turns out the smaller machine works the best. Well, actually, I wanted to take it down to something, you know, really small in size. And it works the best with one winding and not the multiple windings. Tesla made a couple of oscillators just like this. And one of them was the earthquake machine. All right? Where it just does this constantly. Bang, 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 bang. See, and this pulse is a sharp pulse. It's just, see how fast it goes across the pole piece? Okay. And it doesn't make any difference if it's going this fast. It's still doing the same thing. All right? Or if it's going that fast. But it maintains a speed constantly. You know, unless there's no front end on it. And it actually is flip-flopping the batteries backwards and forwards. But they never equal each other because it's always a zero in the center. You see what's happening here? This battery, it finds its center, and then it stays without adding anything to this battery. And in fact, the higher the impedance here, the better this stays charged. So we're using a really small battery here to charge a 100 amp hour diesel battery. Which you can't do with one of these Excite chargers.
This isn't radiant energy, per se.
Yes, it is.
This is radiant energy.
Yeah, it's timed. It's a time wave. It's doing, okay, so there. We can't have no more. So let's see where it got the battery in that amount of time. Right on the button, man. Every time. So you didn't use anything here, look. What did you actually use out of this battery?
14 volts.
You didn't use anything because gravity's aided, adds to this. The only thing we want is the trigger pulse, and we want all the motor force to go away. All right? So if we put a bigger battery on the front here, we can actually, if we give this a little bit more time, here's the unique thing about the pendulum, is there's no boiling of the battery. There's no current that's being taken in massive amounts to charge that battery. It's all about moving one charge in the signal. It's the signal that's important. That signal that we've seen on this. Would you like to see the signal again? So what we have here is a balancing force, and you can see the motor force, and you can see the trigger pulse that it's letting loose. Let's just say we won't be able to test this very well because this is not really a good battery. But let's just suppose we take this dead battery. So you can see the signal that's going to go to the battery. Okay, so there it is. So what we're going to ask this machine to do is balance the battery without taking anything from this battery over here. Okay, and you can see it's balanced the two batteries now. Now we're going to ask for the signal to recharge. And see, it's coming downward. So we're just asking for that signal to recharge it. And so for the battery to recharge, it has to move the lead between the plates. And so that means it's got to come down because its impedance has to go up. And see, now look at the pendulum swing. You can see that it's going much higher than it was with the 100 amp hour battery. So it knows that that impedance is high and that impedance is high. So this is going to come up further. So the crappier this battery is, the higher the pendulum's going to come up and swing on a motor force. And the faster the pulse is going to be to that battery. And there's no feedback
Well, how does it know?
because of the impedance.
Okay.
The impedance of that battery versus this battery versus the circuit.
Yeah.
So this wants to sit at 0 all the time. So it has to make the two batteries balance.
Yeah.
Okay, so is it really in that battery? Is it really putting it over here? It says it is. See, now watch the pendulum when I couple the wrong impedance to it, which is the light. See it? It's going downward. In other words, it knows there's a low impedance here on it. We'll just use the impedance of this battery. It's what Tom Bearden talks about. It's just a sharp transient across the coil that lets this radiant spike loose. See here it's switching on down here, and then bang, it lets it loose. And then the circuit in there catches it, catches the spike. But before, this is a little bit different mechanism than the SG because it balances the batteries. It causes the batteries to rock back and forth.
So essentially you've closed looped it.
Yes, it's closed looped. And essentially this is the primary signal. And let's look at the secondary signal. Get the gain. Look at the signal. Totally different, see? See, there's the switching wave from the pendulum right there, and there's the gain. See, here's the impossibility. The impossibility is that there's no possible way that you can take this battery and put it across that battery and go from 81% to 90%.